We are given two non-empty linked lists that represent two non-negative numbers, where each node contains a single digit and the digits are stored in reversed order. That means that the head node contains the ones digit, the next node contains the tens digit, and so on. The task is to add the two numbers and return the sum as a linked list, again with the digits reversed. So for example, let's say the two numbers we need to add up are 23 and 51, which add up to 74. Then the first linked list would have 3 as the head node, then 2, since the digits are reversed. And the last node always points to a null value to indicate the end of the list. The second list would then have 1 as the first node and 5 as the second node. So if we add them up, we would have a linked list that starts with 4, then points to 7, because 3 plus 1 equals 4, and 2 plus 5 equals 7, and the digits remain in reversed order. We would then return a pointer to the head node as our answer. Now this was an easy example, but it turns out it's not that simple. For example, what if the two numbers we needed to add were 74 and 982? This is more complicated because now a carry to the next digit is generated, so we'll need an additional variable to keep track of the carry. In linked list form, the first list would be 4, then 7, and the second list would be 2, then 8, then 9. 4 plus 2 equals 6, so the first node is just 6. Then 7 plus 8 is 15, so the second node would be 5, and we have to keep track of the carry. Now the first list has reached the end, so we'll ignore that and just do 1 plus 9, which is 10. So the third node is 0 with another carry. Notice that even though both linked lists have ended at this point, we still have a leftover carry, so we have to add one more extra node to our answer for the leftover 1. Now we're finally done, and we can return the head node as our answer. Now let's look at the code and see how we can do this in Python. We're going to use this definition of a linked list here, which has two attributes, the value and next, which points to the next node. We are then given two variables, L1 and L2, which point to the head of each linked list. The first thing we'll do is create an empty node to start building our answer, and we'll call that head. Now technically this value should be initialized to 0, but I'm just going to leave it blank here because this is actually just a placeholder, as you'll see at the end. Then we'll create another variable called current and point that to our head node. Current will be used to actually traverse the new linked list and build our answer. Then we'll create and initialize the carry variable to 0. Then we'll enter the loop that'll add the nodes together. The three conditions to continue looping are that L1 can't be none, L2 can't be none, and the carry can't be 0. If any of these conditions are true, that means we still have more numbers to add. First we'll create a variable called L1 value, which will store the value of the L1 node. The reason why we can't just directly access L1.val is because if we reach the end of the list and L1 becomes none, there will be no such thing as L1.val. So we add a bit of extra logic using this shorthand if-else statement that says, if L1, in other words, if L1 isn't none, then take the value of the node, L1.val. If it is none, then just make it 0. So right now, L1 is a node with a value of 4, so L1 value equals 4. The next line does the same thing, but with L2, so L2 value will be 2. Then we calculate our total, which will be L1 value plus L2 value plus the carry, which is 4 plus 2 plus 0, which equals 6. Then we'll create a new list node to hold the answer, and the value will be the total mod 10. The reason we mod 10 is because dividing by 10 and only taking the remainder will get rid of anything that's in the tens place and keep only what's in the ones place. So 6 mod 10 is just 6. So we'll create a new list node with a value of 6 and build our answer by pointing current.next towards our new node. Then we'll figure out what the carry is by floor dividing total by 10. Floor division rounds down to the nearest whole number, so 6 divided by 10 is 0.6, and 0.6 rounded down is 0, so no carry is generated. The next line moves the L1 pointer to the next node. The reason why we can't just say L1 equals L1.next is, again, if L1 is already at the end of the list, then L1.next doesn't exist. So we say, if L1 is not none, then advance to the next node. Otherwise, just set L1 to none. We then do the same thing to L2, and then we advance current. For the next digit, L1 value equals 7, and L2 value equals 8. The total is then 7 plus 8, which is 15. Now 15 mod 10 is 5, so we'll create a list node with a value of 5, and make that the next node in our answer. Then to find the carry, 15 divided by 10 is 1.5, then rounded down is 1, so a carry of 1 is generated. Then we'll advance L1, L2, and current again. Now notice that L1 does equal none, But L2 doesn't, so we'll loop again. Since L1 is none, L1 value will just be set to 0. L2 value equals 9, and the total is 9 plus 1, which equals 10. Now 10 mod 10 is 0, so we'll create a list node with value 0 and attach that to our answer. Then 10 divided by 10 is 1, then rounded down is still 1, so we have a carry of 1. Now when moving our list pointers, L1 is already none, so we just keep it as none, and we don't advance it. L2 and current advance normally. Now notice that L1 and L2 both equal none, but since carry doesn't equal 0, we still have to loop one more time. Both L1 value and L2 value will be set to 0, and the total is just 1. We'll create a new node with value 1, and now 1 divided by 10, then rounded down, is 0, so the carry is 0. L1 and L2 remain as none, and we'll advance current one last time. Now when we check our loop condition, we see that all three conditions are false. L1 equals none, L2 equals none, and carry equals 0. So we'll exit the loop and just return head.next, which points to this node, and we are done.